let's see how Kepler's laws can be used to determine the mass of the Sun. Look over here. We have an object orbiting the Sun. It's experiencing a force of gravity exerted by the Sun. And since it's the only force pointing towards the center, the centripetal force, or the sum of the centripetal forces, is equal to the force of gravity. Using the equation of the force of gravity, which is g, the universal gravitational constant, times m1 times m2 over r squared, equal to mv squared over r, which is the equation for the centripetal force. Solving for v squared, we get v squared equals g times m2 over r. Make sure to note that m2 is equal to the mass of the Sun, not the mass of the object. Anyways, v is also equal to 2 pi r over t. If you square that, you get 4 pi squared over r squared times r squared over t squared. 4 pi squared r squared over t squared is equal to g times the mass of the Sun over r. Solving for mass of the Sun, or m2, you get 4 pi squared r to the third over g times period, or t squared. You can use this to find the mass of the Sun if you have the period of the orbit of any planet around the Sun and its radius.